Today we're going to continue our study of Chapter 2, Exploring Space. This history gives a foundation we can use to look at the future and what it has in store for us. So far, we've covered the first two sections of this chapter and discussed how our ancestors and more recent explorers got into space. We also described many space projects from the 1990s. Now we're going to look at the Air Force, which leads space activities for the Department of Defense, and learn how the Air Force is organized for space operations. We've got a lot of material to cover, so let's get started. You learned earlier that people have thought about exploring space for all of recorded history. But the Air Force's involvement in space exploration had a very distinct beginning, after which early visions or concepts of space operations began to form. Next, the Gaither Commission helped determine how the Air Force would protect our country against a nuclear attack. The first space tracking stations helped provide important information on what was happening in space, but the launch of Sputnik showed they had crucial flaws. At that time, the Air Force changed its mission to include the word aerospace, which signaled the commitment to discovering how space would benefit our country. Let's continue in our first look at the material for this section. You've probably heard about the North American Air Defense Command, or NORAD, and may have wondered about its mission. We'll talk about NORAD and the anti-ballistic missile programs that keep our country safe. During the Strategic Air Command's era, SAC played an important role in our country's defense. As the Air Force's abilities in space evolved, it needed to create a new command and consolidate space missions. We're going to discuss all these subjects starting at the beginning. Earlier in Section 2.1, we saw that military leaders and historians knew the military could use rockets. But during World War II, Nazi Germany showed that rockets could carry warheads over long distances. After the war, different nations recruited German rocket scientists. The U.S. employed Dr. Wernher von Braun and his team of more than 500 scientists. The team brought with them enough parts to build 68 V-2 rockets. When the U.S. used the atomic bomb to end the war in the Pacific, tensions mounted between Russia and the U.S. Mistrust, national security, and military competition fueled the Cold War, and eventually the space race. The V-2 rocket shown here with Dr. von Braun became the foundation of the U.S. military space program and helped us go to the moon. You may have heard the term think tank and wondered exactly what it means. Well, a think tank usually is a fairly small group of people within a company, corporation, or government organization who research and analyze important topics. The RAND Corporation is an example of a nonprofit think tank focused on global policy. In May 1946, RAND published this article called Preliminary Design of an Experimental World-Circling Spaceship. This publication told our military whether the U.S. could launch satellites into orbit to complete scientific studies, communicate globally, and observe Earth from space. Now, try to imagine for a moment how alarmed the U.S. military was when the Soviets first tested the hydrogen bomb. At the time, we also suspected they were developing systems to deliver long-range missiles, so we had to build up an early warning and tracking system in order to protect our country. Let's look at how that all began. President Dwight D. Eisenhower appointed the Gaither Commission to assess our civil defense following a nuclear attack and to determine whether a U.S. counterstrike was possible. We learned a counterstrike was unlikely because we couldn't predict an attack until the first warhead fell. Based on this intelligence, our country accelerated its Intercontinental Ballistic Missile, or ICBM, program to enable a first strike capability. People say timing is everything, and fortunately, the Gaither Commission report came to President Eisenhower just weeks after the October 1957 launch of Sputnik. In response, the U.S. quickly committed to Project Orbiter, which sought to launch an orbiting satellite on an Army Redstone rocket. At the same time, the Smithsonian Institution was developing an optical tracking network to do its own research on satellite tracking. Once the U.S. was convinced they needed to monitor the Soviet space program, the Naval Research Laboratory developed a network of simple ground tracking stations named Minitrack in 1957 under the Vanguard program. At the time, the U.S. was working on satellites and tracking stations for science, but intelligence sources convinced leaders the military could apply these programs if necessary. After Minitrack was developed, the Smithsonian Institution built a network of Baker-Nunn cameras, like the one shown here called Moonwatch. You may have read about or seen movies about volunteers during World War II who spotted and reported on enemy planes overhead. Well, the Moonwatch scientists asked civilians just like you to phone in when they saw orbiting objects. It seems outdated to us today, but at the time, it worked. We talked earlier about how the launch of Sputnik shocked our country. Take yourself back in time and try to imagine how the U.S. felt when potentially dangerous objects were orbiting in space. We knew keeping an eye on Sputnik was necessary, but Minitrack wasn't performing as well as we'd hoped. So Sputnik was tracked mainly by Moonwatch teams with Baker-Nunn cameras. The Department of Defense's Advanced Research Projects Agency, ARPA, then established Project Shepherd in 1958 to improve Minitrack's tracking performance, and the Air Force Research and Development Command took on the Air Force's space tracking mission. Things were changing so rapidly that the Air Force added a new word, aerospace, to its mission statement in order to recognize the importance of space. Aerospace is a broader term that includes craft operating outside Earth's atmosphere. At the same time, the Advanced Research Projects Agency opened a system program office to develop equipment and techniques that could track space objects and incoming Soviet missiles. By the mid-1960s, the U.S. had 3 radar sites that could warn of an enemy missile attack 15 minutes in advance. These radar sites also tracked other space objects, but in the 1960s, the U.S. was more concerned with possible attacks by enemy missiles. Your parents or grandparents may have told you about bomb shelters and how they rehearsed survival techniques in case of a missile attack by the Soviets. These were scary times for the U.S., but our military was doing everything it could to protect us. Let's talk about one of the most successful programs that made us safe. You may have heard about the North American Air Defense Command, or NORAD, based in Colorado Springs, Colorado. You may also know that NORAD tracks Santa Claus on his trip across the U.S. to deliver toys at Christmas. Well, that's true, but it also cooperates with Canadian military forces to defend North American airspace. NORAD was established in 1957, and here you can see its emblem, which shows the protective wings and sword over North America. Even though tracking stations began monitoring Soviet space programs, new technology in the U.S. and Russia meant that submarines could now launch ballistic missiles. The Air Force developed several radars on the Atlantic, Pacific, and Gulf coasts to detect and warn the U.S. against these submarine-launched ballistic missiles, or SLBMs. By 1972, NORAD managed an entire system of operating radars. Among the radars established for SLBM warning was a new space tracking radar in Florida and the PAVE-PAWS radar sites in Massachusetts, California, Georgia, and Texas. At this time, radar antennas were very large, and operators had to rotate them mechanically to track objects in the sky. To meet this challenge, the U.S. developed something called a phased array to allow electronic steering of the signals while the antennas remained stationary. Let's look again at NORAD, because it has been a major player in Air Force developments and continues to serve the U.S. in military and civilian ways. We can understand more about NORAD when we think about the short version of NORAD's mission statement, which is to deter, detect, defend. The ability to apply this mission statement to both the military and civilian worlds is a testimony to our country's commitment to world peace. Today, NORAD is working with NASA and the Federal Aviation Administration to ensure airspace safety and security. NORAD tracks all space assets like the space shuttle shown on the slide. Here, STS-115 prepares for launch. Today, NORAD tracks more than 9,000 space objects, keeping track of their locations and movements to ensure we don't experience a catastrophic collision in space. When we look at the position of the U.S. and Russia on a globe, We can easily see why the Department of Defense wanted to establish a defensive shield against Soviet missile attacks. The only ICBM site that ever became operational was based in North Dakota to counter-strike if the Soviet Union attacked. But Congress shut down this effort in 1976 because of its expense and its low probability of success. The Air Force eventually took over the system's radars to aid early warning for SLBMs over Hudson Bay, add coverage for early warning against ICBMs, and make space tracking more accurate. By the 1970s, the Air Force had conducted further studies that suggested reorganizations based on our needs at the time. In 1979, the Strategic Air Command, or SAC, based in Omaha, Nebraska, took over administrative control of people and equipment in space surveillance and missile warning missions. NORAD maintained operational control over these missions. Interestingly, SAC's motto is "Peace is our profession," and the men and women at SAC fulfilled that mission during the Cold War we spoke about earlier. The Cold War was the only war ever won without a shot being fired. But the material you've been studying shows this war changed the world we live in. The United States Space Command headquarters, seen here with Colorado Springs Pikes Peak, began in 1982 under the command of General James V. Hardinger. The new Space Command was called a crucial milestone in the evolution of military space operations. At that time, SAC passed operational control of at least 25 space surveillance and missile warning sensors to Space Command. In 2006, General Kevin P. Chilton headed the Air Force Space Command. With a new command formed, the Air Force decided to reorganize by merging several space missions. We'll look at how these missions consolidated, but talking about reorganizing and merging space missions can become a little overwhelming. If you pay close attention and use your text to give you more information on Air Force bases, you'll be able to get the big picture. The Air Force Systems Command controlled much of the Air Force's launch systems, satellite development, and operations. But because they focused more on research and development, they weren't always sensitive to the needs of the fighters using these assets. The Air Force Space Command sought to take over these functions to service the fighters more directly. Air Force Space Command opened the Consolidated Space Operations Center in Colorado to handle operations for all Department of Defense satellites. They also took over control of most Air Force satellites, such as the Global Positioning System, or GPS, that we talked about earlier, the Defense Satellite Communication System, or DSCS, the Defense Support Program, or DSP, and the Milstar Communications satellites. Here you can see the many geographically separated units that belong to the Air Force Space Command. The people who manage and operate these varied units determine our success in space. Just imagine that it takes about 39,000 people to complete the Air Force Space Command's missions, 25,000 active duty military and civilians, and another 13,700 contractor employees. In 1990, the Air Force Space Command took control of all Air Force launch systems and operations, including the launches at Vandenberg Air Force Base in California and Cape Canaveral Air Station, Florida, seen here. This aerial photo of Cape Canaveral with the space shuttle on the launch pad is spectacular because it includes an Air Force jet in the foreground. Space Command develops, maintains, and operates all space launch vehicles. The Atlas, Delta, and Titan vehicles have been the workhorses for space. Atlas V and Delta IV are the most common models in 2006. Here you can see the Atlas II and Delta II launch vehicles. To imagine their power, you need to know they must accelerate their spacecraft contained under the protective shroud on the upper end from near 0 miles per hour to more than 17,000 miles per hour. The Atlas II series had 63 successful flights, with the last launched in August 2004. The amazing Delta II series has had more than 270 successful military, civil, and commercial launches since May 1960. Here on the right, you see the launch of a Delta II in October 2006. We've learned some incredible facts about the Air Force's role in space. They've had to learn fast because of the Cold War and the need to stay strong militarily. We've also had some amazing successes in technology and organization. Following the Cold War, control of all space assets transferred to Space Command, which used lessons learned from the Gulf War to begin deploying teams that support fighters directly in their operational locations. Military downsizing in the 1990s required the closing of several radar sites, tracking stations, and missile wings. Today, the Air Force mission continues to be defend the United States through control and exploitation of air and space. We've come to our activity, so take 10 minutes and answer the 2 questions shown on this slide. Then form groups to discuss how the Air Force contributes to both the military and civilian space communities. Later, you might look up Air Force Space Command in your library or on the Internet to see the latest developments. In this clip, you'll see a simulation of NORAD's space catalog, which contains the many objects in Earth orbits. This clip starts by focusing on individual objects and then shows these space objects are in 2 major rings. Close to the Earth, you can see many objects falling around our planet. As the view pans out, you can also see a ring of spacecraft and debris above the equator, but farther away. This is called the geostationary orbit plane. Finally, you'll get a still picture of the objects in space. NORAD must track all these objects and make sure passing spacecraft or debris don't hit our key space systems. Now that you've been through this last section in Chapter 2, you have a pretty good idea why people have always been fascinated by space and know how we got into space. Our Air Force's involvement in the space community began at a specific time and for a particular reason. You saw how the early visions of space led to the Gaither Commission and their recommendations. You're able to understand how the first space tracking stations and satellites came from our early concepts of space operations. Now, it should make sense that the Air Force added aerospace to its mission statement, and NORAD began. You should have a good idea about the various anti-ballistic missile programs, as well as why the Strategic Air Command formed to support them. Today's Air Force Space Command is completing many missions, thanks to the work done by its founders, other Air Force and DoD units, plus thousands of people who dedicated their lives to keeping our country safe. You know something about the history of space exploration and how courageous